When we talk about complements in probabilities, the complement of A means not A. Either something is A or something is not A. It's either blue or it's not blue. It's either Thursday or it's not Thursday. There's lots of other possibilities, but it can't be both Thursday and not Thursday, and it has to be one or the other. So the notation they use for this, for the probability of not A, is the probability of A with the little dash up here. We read this probability of not A. So since something has to either be A or not A, then the probability that it's A plus the probability that it's not A is always going to add up to 1. So you can solve for the probability of not A as being 1 minus the probability of A. So it might be 40% and 60%, 25% and 75%. It'll always add up to 1. To look at an example, if 2 dice are tossed, what is the probability that neither one is going to be a 5? So here we've got a 1 and a 1, a 1 and a 2, etc. This would be a 3 and a 2. This spot would be a 5 and a 6. I'm not going to fill in the whole thing. If we look at the probability that at least one is a 5, that would be these and these. So the probability of at least one 5 is, we've got a total of 36 in our sample here, 6 by 6. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possibilities that would have at least one 5. We don't want to say 6 here and 6 here because this is where we have to subtract this one that would then be counted twice. This is the intersection. But the probability that at least one of them is a 5 is 11 out of 36. So the probability of having no 5s, 1 minus 11 over 36, or 36 minus 11 36, which would be 25 36. Now, we could have counted all the ones that were not marked out, and that would come out the same. We've actually got 1, 2, 3, 4, 1, 2, 3, 4. So we've got 16 here. We've got 4 here, 4 here, 1 here, which comes to 20 plus 5 is still 25 of the 36 where there is not a 5. So it's just 2 ways of coming up with the same thing. However, sometimes it's much more difficult. In that case, the odds that the die is going to land on a 1 or a 5 or a 6 is exactly the same, and one die has absolutely no effect on how the other one lands. But take a look at this problem. A restaurant has prepared 18 portions of seafood. This came out of the book, don't blame me, don't get sick. But 2 of the portions are spoiled. If 12 of the portions are served to customers, hold your nose here, what is the probability that at least one customer is served spoiled food? Okay, now in this case, when one portion gets served to somebody, that affects how many portions are left, and it changes the odds depending on whether that one was spoiled or not. It changes the odds on whether or not there's still one left to choose from or two left to choose from. And now that since they're saying at least one customer, then we would have to calculate the likelihood that one customer was served spoiled food. Then we would have to calculate the likelihood that two customers were served spoiled food. So this can get pretty complicated. But what if instead we find the probability that no customers are given spoiled food? And then we want to subtract from 1. Okay, so this is a problem where our total possible on the denominator, the total possibilities, we have 8 portions and we're going to choose 12 of them to give to customers. So we've got 18 choose 12. On the top, instead of having to figure it out for 1 and then figure it out for 2, we're just going to figure it out for none. So we've got 16 that are not spoiled, and we're going to choose 12 of those. So we're not calculating the probability that we will choose the 2 that are spoiled. We're calculating that we will choose from the 16 that are not spoiled. Once again, these numbers match. This is from the total sample size, and then this number would be from the ones that we're looking for. So let me run this through the calculator. The top number, this may turn out to be really big and I might want to run the whole thing through at once. We've got 16, choose 12. Okay, it's 1820. And then we have 18, choose 12. $18564. I'm just going to say divided by 1820 and then invert that. And I get 0.098. Okay, so this is the probability that we will not give out any spoiled food. And 1 minus 0.098 is a 90% probability that we will give out spoiled food. So that's scary. Out of 18 portions of seafood where only 2 of them are spoiled, if you give out 12 of those, there is a 90% chance that you just got somebody sick.